Okay, guys, today we're going to look at lesson 4.3 where the lesson objective is to write function rules from words, tables, and graphs. Now, this might be a little confusing, but basically they want us to take information, be able to, 1, find the rate of change, which is, of course, our slope, okay? And then 2, they want us to find the initial value, okay? Which, of course, is our b or y-intercept, all right? So let's come over here first. It says write a function rule for the rule from the words. Okay, so first, remember, when we're looking for a rate, which is our slope, we're looking for the word per. Okay, that's really important. So let's look for that here. I'm going to get my highlighter and I'm going to highlight it when I see it. So let's read it. A rate for internet access is $15 per month plus 25 cents per hour use. Which function rule represents the monthly cost bill? Is it A, B, C, or D? All right, so here's the problem, Miss B. There's 2 pers. I can't have 2 slopes unless I have 2 separate equations, which is not the case. One of them has to be my initial value. And I would say you're right. So let's eliminate one. The internet rate access is $15 per month or plus 25 cents per hour. Let's say you didn't use the internet for an entire month, which I know would never happen, but let's say you did. How much would you pay? You would pay $15 still because you still have to pay that regardless of the hours used. So we can get rid of this per as it. So when I look at it then, the 25 cents per hour is going to be our M. And then the $15 per month will be our B. So let's look. Let's put it in y-intercept form. So y equals mx plus b. Y is going to be our slope or our rate of change as shown above. So what is our slope? Well, we already determined that this was our M and it was 25 cents per hour plus the $15 I'm going to spend initially each month. So which one matches? Well, this is close, but it's got the minus sign. Be careful. So it's not D. It's not this one here because, well, it's not negative 25 cents. That'd be subtracting. 15 plus 20.25x. Okay, this looks close, but it's not in order. Let's make sure it's not this other one. Here they made 15 the rate of change, which we know is not true. So our best answer is B. So let's keep going. So how would I put this into words? I would put that the monthly cost is $15 plus 25 cents times the amount of hours used. Okay? So, what's our blank equal the number of hours, our input? What are we going to put into our equation to get an output? Well, our input is always going to be the x. Okay, remember that's our independent variable. So we're going to make x our input and we're going to let y equal our monthly cost because this will be determined by the number of hours used. So we come down here, and like we made before, y equals 0.25x plus 15. They switched it up, but it doesn't matter. I like writing it like this. And then y equals 0.25x plus 15. So our function rule is y equals 0.25x plus our rate of 15. Now, why did they have the 15 before? Well, we're going to pay $15 plus our 0.25 cents per hour. So they put this here because this is our initial value. I like keeping it in the order that y equals mx plus b has it. All right, so the best choice, again, as we said, was B. And that's how you come up with it from words. All right, let's move on. Bear with me for 1 second. Okay, so now we have the problem, writing a rule from a table. Do the values in the table below represent a linear function? If so, write the linear function rule. Well, in order for it to be a linear function, we have to find the changes in the inputs, all right? And then we also have to look at the changes in the outputs. These need to be the same. And by this, I mean, if you look over here, it has to either increase by the same amount or decrease by the same amount for the x values and the y values. So x and y need to be the same for each letter. They don't need to be the same. X and y do not have to be the same, but they have to increase by the same amount. So let's look over here at our table. To get from 0 to 1, we will add 1, okay? To get from 1 to 2, we added 1 again. So far, so good. And to get from 2 to 3, we added 1. So this one checks. Now, let's look at our y values. We went from 5 to 2, so obviously we subtracted 3. We went from 2 to -1, so we subtracted 3 again. -1 to -4, we subtracted 3. This checks. Look, they're all the same numbers. These are all positive ones, +1 each time in the table. Y is always decreasing by 3. All right, so remember, slope is our change in y over the change of x. And remember, that's shown by a fancy triangle. So let's look at it. So we need to compare the changes as a ratio. So we're going to write y on top. This is where everyone's messing up. Y goes on top. Okay? So y, -3, okay, over 1. Where did these values come from? Well, the -3 came from our change in y, and the 1 came from our change in x. So our slope ends up being just -3. All right. So since the ratio is the same, the function is linear. If it was not, we would say something else, but that's advanced, so let's not focus on it. The slope then, as we said, will be -3, because that's the change in y over the change in x. The point blank blank lies on the graph. Well, 0, and x is 0, because remember, it's always x and then y. 0, 5 lies on the graph of the function. So the y-intercept is 5, okay? Whenever we have 0, some number This number right here is going to be our y-intercept. Okay, so then when we look at this, we can write an equation. Our slope was -3 plus 5. We substitute -3 in for m, since this is our slope, and we substitute +5 in for our b, since this is our y-intercept. That completes video 1. After you are done this video, stop it, turn to the other side of your notes, and continue on to video 2.